So tonight we have Jeff Phillips. He has done some really, really amazing planetary imaging. So I know this is going to appeal to a whole bunch of different groups of people. And we honestly, it feels like we don't talk about planets all that much, and they're really beautiful. So today he's going to share some of his images and how you can replicate the kind of images that he's getting. I will say real quick that I'm going to basically mute everybody so we don't have any background noise. So if you have a question, you can either unmute yourself, which is going to be in the bottom lower left corner if you're on a computer, or pressing the space bar, or you can type them into the chat and I can relay them too. So take it away, Jeff.
Okay. So I haven't done a lot of Zoom meetings. This is maybe my third. I hope the rain doesn't interfere with my satellite. But anyway, I guess, shall I just start sharing and away we go?
I think so.
Okay. All right, now, can you see that? Okay. All right. So I'm a big fan of the planets. And my stepson actually bought a little a Meade 4.5 inch at Costco a few years ago, and he brought it to me and said, you know, help, I can't focus on anything. So I learned how to collimate a telescope, and I was surprised that once that little 4.5 inch refractor or reflector was collimated, I could see the Cassini division in Saturn's rings. I could see the red spot on Jupiter. And it's like, wow, you know, a $200 telescope from Costco can show you these things. And so I've been a fan of looking at the planets ever since. But I also want to make a shout out to the members of the club. This is a fabulous club to belong to. We lost one of our fabulous members this year. While I was going through my favorite pictures to share tonight, this one popped up and I couldn't leave it out. This was part of one of Bill Basham's fabulous Dr. Lapser's fabulous time lapse series. And this is from the Oregon Star Party. So when I got into astronomy, back in the 90s, when I got into astronomy back in the 90s, Earth-based pictures were terrible. I have a copy of the Stars and Planets that this is very similar to one Dan was looking for a home for. The pictures in there, there's one of the pictures. It says right there, one of the best ground-based photos of Saturn ever taken with a 60-inch telescope. And then one of the best ground-based photos of Jupiter. Clearly shows the great red spot. Today, with high-speed webcams, that is a picture of Jupiter taken with a C8, an 8-inch Celestron that I bought secondhand. You can not only see the red spot, you can actually see shading on Ganymede, which Ganymede is about 1.7 arc seconds across. Nobody got that with film. Nobody. And here we are getting these kind of pictures routinely with high-speed webcams and backyard telescopes. So I want to talk a little bit. I want to show you some of my pictures, and then I want to talk a little bit about how we take these kind of pictures. It doesn't take a lot of money. It doesn't take a fancy telescope. It does take patience and practice. You can take really nice pictures with a 90mm telescope. The club has a couple of ETX 90s in the lending library, for example. These pictures were all taken with a Celestron 90mm Maxitov, and this is the Chinese version that retails for about $250. You can see the polar cap on Mars. You can see the Cassini division in Saturn's rings. You can see the Great Red Spot. You can see a lot of detail on the moon. We'll zoom in just a couple of close-ups. Ptolemaeus is one of the big craters there. We'll zoom in on that. This is simply adding a Barlow between the camera and the telescope. You can see multiple craters inside Ptolemaeus. This one, Appianus. I like Appianus because I've worn glasses since I was 8 years old, and it always reminds me of a pair of granny glasses. So, and then this one wasn't actually a C90. This one was taken with one of those little 5-inch f5 Newtonians. Dan was trying to peddle one of these to the club members for the lending library a few weeks ago. But not only can you see Jupiter here, this little black spot, that little black spot, the night before I took this picture, Anthony Wesley of Australia recorded an asteroid striking Jupiter. And I didn't know that. Here I'm taking pictures the next night. Here's this little black spot. That's where the asteroid struck Jupiter the night before. This was taken with an older generation of camera. This was a Celestron Next image, which is based on the Phillips 2U cam, which is just a webcam, which is good at low light. One of the drawbacks of a webcam is it does some processing internally before it ever gets to the computer. It compresses the image, and that the shadow that you see is being cast by Callisto. Callisto's right about here, but you can't see it. Callisto is Jupiter's darkest moon, and the compression has removed it from the data stream. So, but anyway, that's Io over here, Callisto about there, the planet, the moon shadow, and an asteroid impact scar, all captured with a telescope that retails for under $300. So the C90 does a great job on the moon. It's a little small for the planets. So we'll step up to a Celestron C6. This is the double star Castor, and I actually processed this picture to bring out the diffraction rings a little bit. You'll see diffraction rings with a C90 or any small, Maxitov or SCT. If you look closely at a double star, you'll see those diffraction rings. Some people don't like Cassegrain telescopes. They prefer refractors because in a refractor, that diffraction ring is much fainter, but it's not a problem for planetary imaging. It simply reduces the contrast a little bit, and you got Photoshop, you can crank up the contrast as much as you like. So look at a couple of craters, Petavius, Clavius. This is taken with a C6. You can see the rills inside the Gassendi over here. I got a couple of nice images of Mars back in 07. This one was this one I like. Mars was actually farther away, but you can not only see the polar cap here and Syrtis Major, but you can see clouds along the sunset limb. It's pretty cool to be able to see weather on another planet from your own backyard. Jupiter, you can see the Great Red Spot. This one zoomed in again. This again was taken with that next image webcam, which for Jupiter and Saturn, I can only shoot about 5 frames per second, not as good as the newer cameras can do. If you, on cloudy nights, there's a small scope challenge page where people are getting better images with 6-inch or smaller telescopes and the newer cameras. There's a nice one of Saturn when the rings were all about to disappear. So a lot of my best pictures have been taken with a C8. Celestron came out with a C8 around 50 years ago now. These things come up used on Craigslist. This particular one that I own, I got kind of lucky. It was damaged in an auto accident, and the insurance agent had it on display in his office. He'd paid off the original owner for the damaged telescope, had it in his office, and his boss said, you know, you need to get rid of that. So he offered it to the club, and I jumped on it. And it's a great telescope. Some of my best pictures to this day were taken with this secondhand C8. I like this view of the moon. It shows something about the history of the moon. The Imbrium Basin, this is just the edge of it. The Imbrium Basin is like 1,000 kilometers across, a giant impact basin. It would have wiped out pretty much everything within the basin walls here. So everything that you see in there, or all the craters that you see, would have come along afterwards. Archimedes, you can see the floor is flooded with lava. The debris fan that you'd expect to see around a big crater is covered by lava. So this impact would have happened after the Imbrium Basin formed, but before the lava flows. So we have the Imbrium Basin, then we have Archimedes, then we have the lava flows, and then these younger craters come along, and the debris fan splashed out of these younger craters is on top of the lava inside of Archimedes. So you get in one snapshot, you get to see something about the history of the moon. This is obviously Clavius again with the C8 this time. This is Copernicus. This is putting a Barlow lens in between the camera and the telescope and zooming in on Copernicus. And when you zoom in at this level of detail, you can see that the debris from the crater forming impact has, reached out hundreds of miles, and you see that debris all over the place. But this crater is so big, if you put Portland up here at the top, Salem would fit in the bottom, and everything in between would fit inside that crater. Here's a crater Plato. That's another popular one to zoom in on because there's quite a few craterlets inside Plato. These four biggest craterlets inside Plato are about 2 miles across, and that makes them at least double the size of the famous meteor crater in Arizona, the Barringer crater in Arizona. So the Barringer crater in Arizona might be more about this size. This picture of Mars is one of my favorites. A dust storm formed up here, swept across Valles Marineris, and is blowing south and west across the planet. And that suspended dust in the air is illuminating the Grand Canyon of Mars. You can see it because it has the suspended dust in it. Hubble got a picture that showed dust inside Valles Marineris one time, and people in Australia got a similar view again last year. But it's pretty cool, like I say, to be able to see weather on another planet. This one was published in the Celestron catalog a few years back. Jeff Phillips gets his view of Mars from Eugene, Oregon. This is a series of shots over a couple of hours that I sent into International Mars Watch, and you can see that, you can practically see that dust storm swirling around there. This is Solus Lacus, the eye of Mars, and you can even see the eyelashes. So here's a set of Mars images I got this year, back in 2005. And these were all taken with the NextImage webcam at about 10 frames per second. And I was shooting at f/30, and that gave me a surprisingly good level of detail for an 8-inch telescope. This picture of Saturn was taken in 2016. I actually had to transport my telescope up to Eureka Ridge, and battery-powered telescope, battery-powered computer to take this picture. This is my favorite picture of Saturn with the C8. Again, this was using the NextImage, the webcam, and for Saturn I can only shoot 5 frames per second. It's a lot dimmer, so I shoot a video for 5 minutes to capture as many frames as possible, and then I combined 4 of those 5-minute captures with a program called WinJupos, which allows me to derotate the image and combine them. And so this is basically essentially a 20-minute exposure to get that level of detail with an inexpensive camera. Lovely picture of Jupiter here. Not only do I have detail inside the red spot, but I've got a bright spot and a dark spot on Ganymede. And like I say, Ganymede is only 1.7 arc seconds across. Lovely picture of Jupiter. So the last couple of years, I've been using a bigger telescope. I've got a 25-year-old C11. I built an observatory so that I could leave it mounted. And one of my goals last year was to get an image that showed Olympus Mons, the giant volcano on Mars. And that's something that I never managed to do with the C8. And I got some really nice shots of Mars. And so I'll show you that some of those shots pasted alongside some Hubble images just to give you an idea of what you can see. I also this year got some really nice shots of Jupiter and Saturn. One of my images nearly matches the view captured by Damian Peach with a 20-inch telescope one day earlier. And so it's really satisfying to be able to take those kind of pictures. Here's my observatory. My observatory is a little bit above ground level. That helps with moisture coming up from the ground. It also helps with cooling the telescope. And this is actually a fairly extreme moisture environment. In the wintertime, there's actually a seasonal creek that runs across about here. So keeping things up above ground level is a good thing. You notice I have trees around my observatory. This is the view to the south. So this year, Jupiter crossed about here. I get about 45, 50 minutes view of Jupiter. Saturn was only 27 degrees up this year, crossed about here. Only get about 20 to 30 minutes view of Saturn. 2 years ago, actually for the last several years, Saturn has been way down here, which is why I was transporting a telescope up to Eureka Ridge to get a look at it. This is how I attach the camera to the telescope. I have a 2-speed focuser here. The Crayford focuser allows me to focus without worrying about the mirror flop, which is a well-known problem with SCTs. The SCT moves by moving the mirror. Moving the mirror can put the telescope out of collimation. So I avoid that problem by the external focuser. This is an Explore Scientific focal extender. It's a little less expensive version of a TeleVue PowerMate. And most Barlow lenses, the farther you move the camera back, the bigger the image gets. And that can be a problem. You can get an image that's too big and too dim. So this keeps the image fairly constant. It's known as a telecentric Barlow, fairly constant magnification. This gadget here is an atmospheric dispersion corrector. If you look at Saturn, for example, directly with the eyepiece, you'll notice that it's got a lot of color fringing. It's blue on one side and red on the other side. And this device has prisms built into it. I adjust these little knobs to cancel out that color fringing, to bring all the colors back to the same focus. This is a ZWO 224 color camera. A lot of the best planetary images use black and white cameras and color filters. I don't do that. I just use a color camera. And I also have an IR cut filter, a UV IR cut filter, or also known as a luminance filter, on the front of the camera adapter there, so that it filters out infrared. Particularly, infrared will create a lot of false color, especially on Jupiter and Saturn. I'm taking these pictures with a laptop computer, and I'm using a program called Fire Capture. I really like Fire Capture. Fire Capture allows me to blow up the planet on the screen to help make it easier to focus. It's got a histogram display. I like on Jupiter, I like a histogram of about 70%. On Mars, I might go for 80%. On Saturn, I only go for about 25 or 30%. Saturn is almost 10 times as far from the sun as the Earth is, and that means the light on Saturn is only about is 90 times fainter than the light on the surface of the Earth. So I kind of grew up taking pictures. My folks had a dark room in the basement, but if you spend time with cameras, you know that if you're taking pictures at f/30 and you're taking pictures of something that's 90 times fainter than sunlight on Earth, you're going to wind up with a dim, fuzzy, grainy picture. And of course, that's what we were seeing with the film pictures. So that's the reason we take a video and we process the video into a finished product. So here's a picture of Saturn taken with the C11. Saturn was only about 24 degrees above the horizon. So again, this I don't remember whether this was taken at Eureka. I also have a neighbor with a hay field, and I can set up my telescope out in the middle of the pasture and get a lot better horizon. Another picture in 2018, and again, Saturn was only, 23, 24 degrees above the horizon. But here's one I got this year. And I figure I got lucky. In the course of Saturn passing across that gap in the trees, I had really good seeing. And I could process this to bring out the Encke division. I don't really want to push it any farther than I have. I'm starting to get artifacts. I'm starting to get extra color. I'm starting to get artifacts in the rings. If you go on Alpo Japan and look at a variety of Saturn pictures by a variety of photographers, you'll see lots of extra rings, and a lot of those aren't really there. They're sharpening artifacts. But when I posted this on the club bulletin board, Mel said, "Jeff, you got the polar hexagon in there." Well, so I went looking for the polar hexagon. This is an extremely stretched version of a polar projection. And by golly, there is a polar hexagon in there. That's an elusive target this year. A fellow from Australia was able to pick that up with a 16-inch telescope and an infrared filter. But a lot of people have struggled to catch that polar hexagon this year. So I got pretty lucky on that Saturn image. Here's a Mars image from 2016. Again, we're looking at a maximum elevation of about 24 degrees. This again is a picture that I had to transport the telescope in order to take pictures. Elysium Mons is the volcano here. Olympus Mons is here, but it's under a cloud, and the other volcanoes along the Tharsis Plateau are under clouds. So I still wanted a better picture than that. So last year, everything really worked out well. In spite of the fires, I was able to shoot a lot of pictures through the smoke. This one I was really happy with. This one was published both by the Register Guard and by Channel 9 News. The Channel 9 weatherman actually blew this up full screen. He was pretty impressed. This might be my best shot last year. This is again, this is Syrtis Major. There are several, that's a crater named after Huygens. There are actually several craters actually visible in this picture. This light area here is an area called Hellas, and that is an impact basin on Mars. And in this picture, you can see, much like some of the giant impact basins on the moon, it's a multi-ring basin. It's got an inner ring and an outer ring of mountains. So I was pleased to see that.
Jeff, shooting through the smoke, and I want to know if that requires a particular kind of post-processing, or are we just talking luck?
Well, fortunately, Mars has a lot of red, and the red penetrates smoke. Depending on the amount of smoke, I would have to increase the gain in the blue channel and turn down the red to compensate, to try to come up with a realistic color. And if you go back and look at the early Hubble telescope pictures of Mars, they're quite red. And part of the reason for that is people call Mars the red planet. But if you look at it, Mars in a telescope, it's more of a peach color. It's not really red. And Hubble has adjusted their Mars color palette over the years to try to come up with a little more realistic color. So here's a Hubble picture of Mars from 2003. They weren't quite. This was just sort of a rough sketch. They hadn't gotten some of the hardware out of the way, but it corresponds almost exactly to what I was able to get with the C14, and on October 2nd, which is a couple weeks before Mars opposition. This area down here is it's another impact basin. It's called Argyre, and again, I was surprised to see that this is an obvious multi-ring impact basin. And one of the other things that surprised me, part of Vales Marineris, I think it's Coprides Chasma. You can see in the Hubble picture. I actually managed to pick that up. Oh, and one of the fellows on the club list was talking about a little linear feature coming off of Arsia Mons. Arsia Mons is a volcano right there. This little linear feature is actually a shadow. There's a linear cloud, and the linear cloud is casting a shadow on the cloud deck below. And you see that sometimes in the backyard. You'll see a contrail will cast a shadow on the lower cloud deck, and so I managed to catch a little of that shadow cast by a linear cloud from Arsia Mons. Here's Olympus Mons in the Hubble image. Here's Olympus Mons with the 11-inch telescope. And then I also was playing with an antique 40-year-old C14 last year, and the C14 had some astigmatism, but I managed to get some good pictures anyway. So there we have it. I succeeded in my goal of capturing Olympus Mons. So here's Jupiter from a couple years ago, and one of the interesting things about this one, I captured this on March 8th. On March 9th, Damian Peach captured the same side of Jupiter, and this was about 2 a.m. local time in England. Damian Peach shooting with a 14-inch telescope. And here, 10 hours after that, Chris Go got the same side of Jupiter. And so you can see 3 different versions of Jupiter. And one of the things you can see in these 3 different versions, Damian Peach is famous for taking a nice, smooth approach to processing. He comes up with a nice, smooth picture. This area down here isn't nearly as pronounced as it is in my picture. I have over sharpened this picture. Obviously, I do that to bring out the nice details, but compared to Damien's, it's over sharpened. And then Chris Go is somewhere in between. And if you look at a lot of Chris Go pictures, Chris Go sharpens it until the noise becomes a problem, and then he uses topaz denoise to filter the noise out. So Chris Go, Damian Peach, Jeff Phillips, and so my image isn't really sharper than those other images. It's somewhat less sharp, but I've overdone the processing a lot to try to bring out the details. There's mine right next to Chris Go's. And so I'm learning how to process these better and not over sharpen it too much. Here's another one from February 24th of 15. And on this one, that's the moon Io. You can actually start to see darker poles and a dark patch across the middle. We're actually seeing a detail on Io, and Io is only 1.2 arc seconds across. And in order to bring out this kind of detail, I'm shooting at 7 to 10 pixels per arc second. So here we have a moon that's maybe 12 pixels across. Here's a picture from this year. This oval in the southern region is formerly oval BA. It was tagged Red Spot Junior a couple of years ago because it was just as red as the Great Red Spot. It's faded, but you can actually see little swirls inside that little spot. Here's on the 22nd. This white spot in the north equatorial belt wasn't even there a week or two prior to this. And then this is the best shot I got. This was on the 28th. And in this one, this is something that's obviously eluded me with the 8-inch telescope. You can actually see little swirls inside the Great Red Spot on this. Here's a picture by Damian Peach, and Damian's picture was taken on the 27th with a 20-inch telescope. And I'm not sure where this telescope was located. It may be part of the Chilescope complex. The main Chilescope is a 1 meter telescope. This one's only a 1/2 meter, only 20 inches. But there's my picture next to Damien. And if you look at this little tiny details down here, obviously mine isn't as good. But if you think about, inch for inch, 11 versus 20, that's a pretty darn good image. It's a delightful image, and I'm really pleased with it. So the technique for taking these pictures is called lucky imaging. And part of it, I initially didn't want to call it that, but I have to admit it's an appropriate name because it takes a bit of luck. And the issue is, how do you improve your luck? When I shared that set of 6 different pictures of Mars on some of the forums, they say, "My golly, you must have some good seeing where you live." And that's partly true. Damian Peach gets a lot of his good pictures by transporting his telescope to Barbados in the Caribbean. Chris Go would tell you that part of the reason he takes such good pictures is that, being in the Philippines, he's got a tropical island, a tropical island environment where the temperature is fairly constant. And if you look at images on Alpo, Japan, a lot of the best, most consistent images are people that, Curacao in the Dutch Indies, places like that. David Hamilton had a picture of Saturn published in last month's Sky and Telescope. He lives in Puerto Rico. So some of these places really have really good seeing, but we get pretty good seeing here in the Northwest because of the influence of the ocean. So if you look at Clear Sky's chart, if you look at it a lot, you will see that a lot of the best seeing comes after midnight. That after midnight, it's not at all uncommon to see that CSC rating up in the 4 or even 5. 5 isn't so common, but 4 is common, and it's most common after midnight. So, that's one of the reasons I'll get up at 2 or 3 a.m., take those pictures, because that's when the seeing is best. Collimation is really critical. I mean, collimation is unbelievably critical. Thierry Legault wrote a very good article. It might be a 20 years old article now, but it's as good as ever. That you can't just center the donut of an out-of-focus star. You need to take the time to center the airy disk. And the people that get their images published, in the magazines and Astronomy Picture of the Day, those kind of folks, they'll fine tune that collimation every night. They'll at least check it every night. This is the double-double. These are close enough that when I take the Barlow lens out of the system, I can image both pairs with the C11. Zooming in on one, and then using a process in AutoStacker called Drizzle to blow it up 3 times, artificially blow it up 3 times what the Barlow lens does. You can see I've got a pretty good collimation. I've got a pretty good optical figure on the C11. But the other pair on the other side of the chip, those diffraction rings aren't centered anymore. Just, from one side of the chip to the other, the collimation is no longer perfect. Jerry, with his last month or the month before, talked about collimating his travel scope. He talked about how there's a sweet spot, and sometimes that sweet spot is off to the side, and you want to bring the sweet spot into the center of your eyepiece. Same thing with imaging. You want to bring that sweet spot into the center of the chip. Another issue with a bigger telescope is it needs cooling. With the C8, I can set the telescope out after dinner, be good to go in an hour. With the C11, that's not good enough. I open the door and the hatch on the observatory, and I'll do that in the evening as soon as the sun goes down. And then usually by 2 a.m. it's cooled off sufficiently. But sometimes I'll, on top of especially if I'm going to be imaging earlier in the evening, I'll put an artificial ice pack or 2 on the rear cell of the telescope to artificially cool off the scope. When I use the C14, I pretty much always have to use artificial cooling. That great picture of the eye of Mars that I used for my teaser. I put so many ice packs on the scope that I was getting condensation on the outside of the telescope. I was getting condensation on the inside of the telescope. The following morning, there was condensation dripping out of the telescope, but it worked. Now, Crisco in the Philippines doesn't have to deal with the kind of temperature differences from night to day that we do, but he's cut holes in his C14 to install cooling fans. Daryl Millica in Australia, in the outback, He's get a more extreme temperature difference than we do. And so what he does is he will put, he's been known to put his telescope in a plastic bag, put the whole thing in a plastic tub, and then throw 20 pounds of ice on top of it, and then add salt to the ice because he needs it to be below 0 degrees C by the time he's imaging. Damian Peach, there were pictures of him setting his telescope in front of the air conditioner while he's out there in Barbados. He's cooling off his telescope so it'll be ready to go when the evening comes. And the reason for that is, if you think about it, light gathering power increases with the square of the aperture, but thermal mass increases with the cube. A Meade 12-inch telescope can weigh 8 times as much as a little C6. So cooling matters. All of these little details matter. We're trying to capture detail that's smaller than an arc second. We're pushing the telescope as far as it will go. So here I am in February. I've got frost on the dew shield. This dew shield, by the way, this is a foil-lined foam that you use to protect your car dashboard from the sun. It's just the right size to wrap around the telescope. So I've got a hairdryer down here in case I need to clear the frost off the corrector on the front of the telescope. I have a plastic bag over my camera. I actually have to keep the camera a little bit warm. If you're a deep sky imager, that might seem counterintuitive, but it turns out this camera doesn't work very well if it gets frost inside it. So I put a plastic bag over it to keep it a little bit warm. You can see with fire capture, I can blow up a nice big picture on the screen, and that allows me to focus. So some imagers are having success with limited success with automatic focusing. SharpCap has a new focusing routine, the Fourier detail focusing. It works some of the time, but most experienced imagers simply focus by eye. Daryl Millica, some of his ancestors are Australian Aborigines. He figures that he inherited some of their tracking skill, and he uses that skill to help him focus on the moving target. Damian Peach brings a computer, not just his laptop. He brings a monitor screen out to the observatory with him so that he can get a bigger picture to work with. These guys focus by eye. I focus by eye. With Mars, there was a lot of high contrast detail to work with. Jupiter can be a little harder. So this is Jupiter with the C8. And we'll see if the video actually plays for us tonight. There we go. This is a good night. This is a night that's probably 4 out of 5 on that image scale or the seeing scale. Up here we have Europa. Europa is 1 arc second across. You can see it's jumping around and even bouncing in and out of view, but most of the time it's actually a little disk there. Another detail here, the white band around the great red spot, again, that's a detail that's that's about a 1 arcsecond detail. So when we're trying to focus the telescope, when I'm trying to focus the telescope, I actually think of it as in terms of touching the focus knob lightly and think about turning. It's just the tiniest little bit of focus. And one of the things I've noticed over the years is that the focal point for bright details is not necessarily the same as the focal point for dark details. I don't know why that is. But when I'm focusing on a planet, a lot of the time, what I want to see is the little tiny dark details. And so I have used like a double star or something to focus with, but for the most part, I just focus directly on the planet. I try to bring out the best detail that I can. And then I hit the record button on my fire capture. So this is a series of shots that I took over, actually the whole night, it was maybe over 2 hours, shooting several 3-minute videos. I typically capture a 3-minute video on Jupiter. I typically go 4 minutes on Mars. I typically go 5 minutes on Saturn. But so we're stepping through a series of processed images where I've run the 3-minute video through my stacking software, and I've run it through Registax to sharpen it. And we're stepping through here, and you notice that in spite of my best efforts, not every one of these is a good image, but some of them are very good. And so my process is to sharpen a whole batch of images, and I may take 50 gigabytes or more worth of video in the course of one evening. AutoStacker will process these in a batch, and Registax will save my settings so I can step through these and then look through them and pick out the best ones. And then the best ones can be combined with WinJupos and maybe just a little bit of deconvolution. And that is a stunning image to get with an 8-inch telescope. Probably my best ever with the 8-inch telescope. Whoops. And of course, I like to send it into Alpo Japan or some of the other websites and compare my results with other people. So I recommend, if you want to do this, I really recommend getting some advice from the real experts. There world-class experts out there are willing to share their advice. I will email links to all these things that I'm showing you tonight. I'll email the link in the morning. This is a great talk by Damien Peach. This was a Zoom meeting recorded by the Westport Astronomical Society. And so Damien takes about an hour to talk about his process and answer questions. Telescopes.net invited Christopher Go to do a seminar, and he went into a lot more detail. So this is a 3-part series of lectures. Each lecture is over an hour, So Chris Go started getting his pictures published in Sky and Telescope when he was still using a C8 and a 2-cam webcam. So he's been on the leading edge of planetary photography for years. Damien, by the way, has worked out deals with the Chilescope organization and some others where he can actually go in and use a 1 meter telescope, 40-inch telescope. And so a lot of his work on Mars last year was with the 1 meter Chilescope. Daryl Millica is a really interesting character. He's from Australia. He really enjoys sharing the knowledge and encourage people to get out there. And so he's posted a lot of tutorials on what it takes to really capture these great images and then how to process them. So Daryl participates in the Cloudy Nights astronomy forum and is a great guy and great at encouraging people. Thierry Legault, classic article on the collimation and how big a difference it makes. You can turn your 8-inch telescope into a 4-inch telescope by having it out at collimation, or you can tune it up and get the best possible views. Fire capture, I really like fire capture. One of the neat things about fire capture was written by a fellow in Germany, Torsten Edelman. Torsten participates in some of the forums, but he's also developed his own tutorials. Fire capture is very complicated, but he lays out step by step. Here's how you do it. Here are the tools you can use. So he's got a whole series of tutorials on his website. Two of the best image stacking programs both come from Holland, Registax and AutoStacker. Registax kind of hit a barrier when it got to multi-point alignment. Multi-point alignment is very useful for planetary imaging and for lunar imaging. When I was trying to do multi-point alignment with Registax, some of the alignment points would start wandering off into the distance and get lost altogether. So Emil Kraukamp has worked out techniques to make that multi-point alignment work and work very well. And Daryl Millica's tutorial talks about using 50 alignment points on Jupiter. And so I've taken that to heart, and I use 50 alignment points more or less on Jupiter. And it works. It's amazing. Registax is still one of the best programs for sharpening. There are others. And some of the others may be better, but I've been using Registax for years and I still use it and still like it. So, it's been an effort. I put a lot of time into it to making it work, but to me, it's worth it. Some people say, why would you bother when you can get such great pictures from the Hubble? Well, for one thing, sometimes I can capture a dust storm that the Hubble didn't capture. But there you have one of the iconic Hubble images. And I love comparing mine, you know, for for an 11-inch telescope in my backyard, it's pretty damn good. This one I sent around the other day, I came across this astronomy picture of the day by Damian Peach with the 1 meter chili scope on the left, and then my picture with the C14. I don't know. Maybe the chili scope wasn't having the best seeing that night. I don't know, but my picture is awfully comparable. Here's another picture taken with the 1 meter chili scope. This one was published in Sky and Telescope in the latest issue in November. And here's my picture side by side with Damien's picture. And yeah, Damien's is better, but it's awfully satisfying to be able to take this kind of picture from my own backyard. Here's another picture. This picture was taken with the 1 meter telescope at Pic du Midi. And this picture, along with a picture of Saturn and Mars, was featured as an astronomy picture of the day a few years back. So that was taken in May of 16. Mine was taken in May of 16 with an 8-inch telescope from my backyard. So, you know, it's just a fun thing to do and very satisfying. So there you have it. Any questions?
Very good, Jeff. That was beautiful stuff. So that atmospheric dispersion corrector, I struggled with it. I bought one, and I struggled with it a little bit on how to fine tune and get it just right. How do you do it?
Fire Capture has a tool that allows you to it exaggerates the colors. It basically picks out just red and blue, and it'll show you a little bouncing ball, and it has some tools to average out that bouncing ball so it doesn't bounce so bad. And it takes a little while. It takes a little practice. And I don't really get it perfect, but AutoStacker has an align the color frames checkbox. So I get it as close as I can, and then AutoStacker takes it the rest of the way.
Yeah, I was using that in Fire Capture, and I just couldn't get the balls really, really close. And I didn't know if it was me or if it was the seeing.
You know, you have that in common with a lot of people, Mark. It's basically, if you put those bars together, you should get blue on one side and red on the other.
Right.
And you should be able to twist them together until they're on top of each other, until they're vertical, and then spread them apart, spread the little bars apart, and the ball should come together.
Yeah.
And
I was just, I didn't know if I was ham-handed or I had to be more finesse to it.
It's, you know, there was a fellow in Singapore, Tan Wei Long, and he would participate in the forums, and he would get his pictures published on Sky and Telescope. And somebody said on the forums, he said, so what's the secret? What's the secret to being able to take such great pictures? And he came back with a very oriental answer. He said, patience and practice. And to me, that is, that really is the secret sauce, patience and practice.
Yep.
Get out there and try it some more.
Now, the other question
After a while, you don't feel so ham-handed.
Yeah. So the other question is, how often do you rotate and re-level the camera system with the ADC on it?
John Boudreau with his C14 did some experiments with, and he says maybe as often as every 20 to 30 minutes.
Okay. Yeah.
Now, if you're shooting near culmination, like I say, that gap in the trees that I've got, that works to my advantage. I can set it once because it's within 20 minutes one way or the other. And so I can set it once and I can leave it there for a couple nights, nights in a row. Okay. I might touch it up, but basically I will, my best shots this year, I left it set from what I had the night before. I went up to, which star did I use? I think I used Altair, which is quite a bit higher in the sky. I fine-tuned my collimation. My collimation was kind of an oval with red on one side and blue on the other. I didn't mess with the ADC. I just adjusted the collimation, brought it back down, and it was perfect. And like I say, as it crossed the meridian, everything was dialed in. That was a good night.
Hey, Jeff, speaking of
Jeff.
collimation and telescopes and so forth, are any of these pictures taken with EAS club telescopes? I think you're holding one or two of them. Are any club hardware you could show off for us?
We'll talk about that. No, basically not. I did take some pictures of Mars last year with a club telescope. And I have to tell you, the best view of Saturn I've ever had was with the club 12-inch.
Oh,
that's a wonderful telescope. And the only time I have seen the Encke division in Saturn's rings was with that telescope.
thanks, Jeff. Great talk.
Could you,
Thank you.
are focusing your mirror, moving that whole big mirror, where do you leave it before you start using the rack and pinion focuser you added to the back?
Yeah, I bring it, I basically pick out the 1 centimeter mark on the Crayford focuser. It has little markings on there. I set it to 1 centimeter. I dial it in the best I can with the moving mirror. I make sure that the last time I touch that moving mirror, I'm going counterclockwise, and then I leave it alone and do the rest of my focusing with the Crayford.
Thank you.
I know you guys have more questions.
Well, I got a couple quick ones, and you talked about the economy of what you're doing, and I'm just wondering, how much is the NextCam camera cost versus the ZWO camera?
Well, the reason the reason I first bought my first ZWO camera was Windows, Microsoft in their wisdom made it so that my next image didn't work anymore. And I could not, you know, I can either carry my old XP laptop out to the telescope and use that, or I had to get a new camera. And so people were saying good things about the ZWO, so I bought one. But the camera I'm using retails today for $200. So it's a real bargain. It's a real bargain. It's sort of it's a 5-year-old model now. It's not the latest and greatest, but
Very good. Is the fire capture free software?
free software. Yeah.
Great.
All of them are.
Yeah. Fire capture, auto stacker, Registax, all free. Yep.
Great talk, Jeff. Thank you very, very much. Amazing pictures.
You're welcome.
What's the mount that your telescope is on?
I am using Losmondi G11, and I bought it used from a fellow in Florida, and he used to leave it outside year-round with a cover over it. And so last year, when the smoke was at its thickest, I took advantage of the time off to pull it all apart and clean and relubricate the bearings. And there was actually quite a bit of sand, Florida sand, beach sand in the bearings. So it's working much better today.
Are you using periodic correction on the mount or not?
I am not.
Yeah, 'cause I noticed that the only drift I had was periodic.
One of the neat things about fire capture, which I've only started using this year, is it will guide for you. In fact, if I go back to all the way to where we had pictures of the mount. Come on. Okay, you see there's 2 wires coming off the camera. One of them is going to the computer for the signal. The other wire is actually going to the auto guide port on the mount. And fire capture has a setting that will automatically use the auto guide port and keep your planet in the center of your field of view.
Do you have to use the ST4 guiding with fire capture, or will it do pulse guiding command?
I think it will. I think it will do pulse guiding.
I couldn't get it to work.
Well, maybe, yeah. Like I say, I just started using it this fall, so I haven't used other mounts with it. I used to just kind of sit there with a little, 4-button controller in my hand, and the smaller my the smaller my region of interest is, the smaller box that I'm putting that planet in, the more I would have to sit there with my thumbs on the buttons and keep it centered. And like I say, I've discovered that fire capture can do that for me.
Yeah, I wasn't successful with the guiding, but I used the auto center, the ROI feature that fire capture has, and it didn't wander too far. The only thing I saw was really the peck error on the mount.
Right.
That I'd see it drift out and drift back. And then how often do you refocus?
Pardon? How often do I refocus?
refocus? Yeah.
I tend to, I'll shoot a 3 or a 5 minute video and then I'll touch that focus knob and see if I can make it any better.
Okay.
So I will refocus between each shot. Unless it's looking really good, and then I'll just hit the button and keep capturing.
I have a note from Dan in chat about the board meeting real quick. Andy texted him earlier to say he got kicked off because they needed the Zoom portal for another meeting. Without Jerry here too, do we continue or hold off on the board presidential part of the vote?
I have proxy votes for both Ken and Jerry, so we will go ahead. And I think Andy is back, but let's finish this up first.
Yeah. I love all the Jupiter stuff because Jupiter's like a sentimental favorite for me. It's the first thing I ever found in a telescope all by myself. So I loved that. I think they're gorgeous.
No. Yeah, that's my best Jupiter ever. No question about it.
Totally awesome.
We have any more questions? He did mention sending out some links, and I just wanted to let everybody know, I know that we have other groups here, so I'll make sure those get forwarded to the groups.io for Heart of the Valley, Night Sky 45, and astrophotographers of the Pacific Northwest too. So y'all will get included. I love that everyone is here for this. We had a ton of people tonight, and I think it was really a wonderful presentation.
It was.
Thank you very much, Jeff. And don't think
That's great.
up again. We will.
Yeah, I thought it was terrific as well.
Thank you.
We'll get you back on.
Yeah, you got a lot more to do, Jeff. It's really good. Hey, have you done Venus?
The only Venus I have was taken with a little 4-inch Maxitov, and I have not got an ultraviolet filter to get those really great pictures.
How about Uranus or Neptune? With your big
I got Uranus last year, and or maybe it was the year before. It may have been in the year before. I was actually able to pick up a little. I used an infrared filter. I was able to pick up a little banding on Uranus, or it's one of my cases of over sharpening. One of the two. Could be that I didn't pick up a band, but it looked a little like Damien's picture, so I was happy with.
He's always the gold standard.
He is.
Well, thank you, Jeff.
Yeah, thanks, Jeff. It was great.
I thank you.
Okay.